and difference of cubes. Right off the bat, you see that it's not just difference of cubes. The sum formula will work this time. So there's two of these. The plus one will work this time. You use the sum and difference of cubes when you are given two terms again, but you're going to see they're going to be cube values instead of squared. And then right here I just say, yes, you can do both sum and difference, adding or subtracting. Okay, so here's the pattern for this one. See, the same setup, right? A squared minus b squared, but this one's a cubed minus b cubed. Here's what you get. You get a minus b, which is very similar to the last one. Or it starts out very similar to the last one. And then it goes to this. Looks harder than it is. I'll explain it. A squared plus ab plus b squared. So I'll explain it and I'll break it down. Again, guys, if you actually, you'd have to do this. You'd have to distribute A to all three of these. I'll do it very quickly. Then you'd have to distribute negative B to all three of these. Negative A squared B minus AB squared minus B cubed. And what happens is both of those sets of inside terms cancel. And you get A cubed minus B cubed. So again, I'm just showing you why it works there. You distribute the A and the B, the negative B to every term, and things cancel.
Oh, I wasn't done.
Well, I was just, okay, sorry. I'm just showing you why it works. Let me start to explain the formula. So you do the same as before. You get an A and a B value, and they go there with a minus. Then, here's what I always like to say on this part, is you square the sides, multiply the middle. You take your A and your B, you square them on the sides here of this trinomial. Square the sides. Square A, square B. And in the middle, multiply. You multiply A and B in the middle. You'll also hear this. I'm sure if you haven't heard it yet, you'll hear it in the future. SOAP. You'll see people will just say, oh, this is a SOAP problem. This helps you to know what sign it is. So you look at this negative here. So S is same. So this one is negative. This one's opposite of the original one, so it's positive. This one here is always positive. That's how it can help you remember the signs of those. So SOAP problem really is a sum or difference of cubes problem. Now, let me show you. It's the exact same setup for plus, it's just different signs. So A cubed plus B cubed will work here. It's A plus B. Again, here I'll go ahead and get rid of this temporarily. So let's see, it's positive there. Then over here, I square the sides. It's the same as the other one. I square A squared. I square B on the side, B squared. In the middle, I multiply A times B. This is the opposite sign of the original, so it's minus, and this one is always positive. AB. I know the formulas look a little bit more confusing, but they break down. It's again kind of a formula, and they break down pretty easy once you get used to it. How about any additional thoughts on the formulas there? So then, list of perfect cubes. So it's good to recognize, just like before the squares. Let's go up to about 7 or so for these. 1 cubed is 1. What's 2 cubed? 8. 3 cubed? 27. Not 9 is 3 squared. 4 cubed?
64.
64. 4 times 4, 16 times 4, 64. 5 cubed?
125.
125. Yeah, it's 25 times 5. Like 5 times 5 is 25 times 5. Anybody know 6 cubed? Yeah, 36 times 6.
Oh, I know. 36 times, I don't know.
18 plus 3, 2, 16.
Nice. Good mental math there. And then I'll stop with 7, 343. Now you might see 8 cubed, 9 cubed, 10 cubed is 1,000. But you don't see too many more above that, roughly around 6 to 7. So if you see one of these numbers, oh, and you see like an x cubed, probably a sum or difference in cubes problem. Okay, let's try.
Did he scare you?
Gorillas.
That was super loud.
Bless you, thanks.
My class, no.
Like it's so.
It's like high pitched and really loud. It scares you.
Who, Taylor?
Yes.
Oh my gosh, she was in my Spanish class last year.
Anyway, let's go.
Yeah, let's continue. Let's learn. Factor completely. If it cannot be factored, right prime. Let's do A. X cubed plus 8. No GCF. So then I go on, instead of a square root, I'm doing a cube root. So basically I'm doing a cube root of each of these. X is my A value. And 2, yeah, is my B value. So I'll write this one, I'll write it like this. A is really X, and B is really 2 in the formula. And again, really, we're trying to write it like this, as some value cubed. So it's really X cubed plus, and then 2 cubed. So that's how we get our A as X, and our B is 2. Okay, then I just plug in the formula. So it starts off, this one, A plus B. So it's X plus 2. And we can already see that's the same. Over here it's going to be opposite, and then always positive. Instead of my trinomial. So then I know I can just follow the formula over there, but all I ever do is square the sides. First one, I gotta go in order. X squared, A squared, X squared. Over here it's 2 squared, B squared, 2 squared, 4. And in the middle it's A times B, 2x. Good. And yeah, it would be a good idea to write it as 4, not 2 squared. Yeah.
So for both A.
Yeah, but both of these work. So yeah, for the signs.
How did you get to
A times B.
I got it.
A times B in the middle, so X times 2. Which yeah, I could have written first as X times 2 and then 2x.
Yeah, that's right. Okay. I was looking at my answers.
Instead of 2 squared?
Yeah.
It's technically right, but I'd prefer.
Either way.
Yeah, but I prefer 4. Instead of 2 squared. Okay, good. Good questions too. Any other questions on that one? Let's do one more with a minus, and let's see where we're at. I can do a third one. Sure. But let's do B. Yeah?
Is that factored completely?
Yeah. Yeah, right here. Now,
But then
you're right. Okay. Most of the time, these will not be able to be factored by a trinomial when you get to here. But you're right. We really should try and get to here and say, all right, what 2 numbers multiply to get 4 and add to get -2? It's not going to work. There's no number. But thank you for saying that. We should try and factor that one more. It's just that there's not going to be any 2 numbers that work.
So you don't have to put anything on the outside. Just kind of.
Right.
Okay.
We're good there. And this one, it was good to try it, but it can't be factored in.
So what happens if you have a number and you divide? So like you find the GCF.
Yeah.
And then you do the cube root. Would you
Yeah, then
put
the
that
number stays on the outside.
Okay.
Like on this one, you would have to factor out a 2. And it'd be this. And then you just keep the 2 on the outside, and then you'd have all that set up. Let's go back and do B, a difference one. Okay, so there's no GCF here. 125, 216, not a GCF. But each of these is a cube value, perfect cube. So I do a cube root of 125 to get 5 and x for the x cubed. Here, cube root is 6. So I can go ahead and put this in parentheses and do a SOAP setup. That was a minus, so this is same. opposite here, positive.
Ooh.
Always positive here. And then for my trinomial, a squared and b squared on the outside. So I square the sides.
Oh.
So I squared 5x. So now here's again where it's it's 5x squared that's going to go here. Let's write it as 5 squared 25 and x squared x squared.
Oh, what do you have to do that?
Whoa.
Wait, I
Okay.
didn't get that.
This is a squared here.
Oh. What?
And so this is a. This is
Okay.
a.
Okay. I understand it
And this
now.
is two.
So would you just
Oh.
write 25x or would you write?
25x squared.
Because these x is still squared.
X is squared too.
Wait,
Wait, so this one.
So then this one over here is 6 squared, which is 36. So I squared the sides. 5x squared and 6 squared. And in the middle it's AB. So I multiply 5x and 6. 30x. And that's it. Now, I do have some time. Any questions on that one? And do you want me to do C or D?
What?
Look at our silly mans.
Wow.